5-3 is the next problem I work on. 15-3, sorry, 15-3. Let's see. All right, next welding half-inch by 6 mile steel flat bar. So we have two pieces of half-inch by 6 mile steel. Yeah, this one isn't too much different than the last one we just did. So this will probably be pretty clear. Just analyze this weld. So it's kind of like it's down to it's kind of I start to read these hieroglyphics. Okay, so I recognize this arrow sign. It's been got the arrows going to be. We've got a V here. Well, it's not a V here. Yeah, it is. It's not a V. Sorry. I was thinking it was all double bevel, but there's single and double bevel. Yeah. So, I didn't call it double bevel, but this is a V. So both sides are going to, and both plates are going to have some preparation. And then this one just goes right into what I was explaining in that last video. Is that we have two different sizes here, and what that is theoretical side kind of on the depth there on the left side, yeah, 3/8, and that's going to be through half-inch plates. So this is an occasion where at least in this part, we're not going through the whole thickness. We're actually only doing a 3/8 depth. And then the half-inch there is maybe my allowed size if I love it. So it can be half-inch, which doesn't mean it's necessarily going to be through the whole thickness of the plate. In fact, my joint prep isn't going to include it through the thickness of the plate. I'm actually only going to bevel like 3/8 of that. So there will be about 1/8 of an inch of material that's just kind of butting into it. And some of that will get consumed into the ground. But I'm not necessarily specifying that it all has to get consumed either. So there's a way to specify that. That's not what this is saying. This is just saying that, I understand that as I do this 3/8 weld, there's going to be probably some depth of weld below the depth of the bevel, and there'll probably likely be some weld that is above. Um, it's where my weld size is going to need to be within this like half-inch division. Oh, right. So, and maybe that's going to be measured. Like it's that effective throw. So it's going to need my weld size is going to need to measure half-inch through without necessarily being 100% weld between these two pieces of metal. It's kind of a unique situation. It's almost like I've trucked up a weld that I don't want it to go through to the other side. Like I haven't strategically like pulled them apart so that I must make myself weld completely through these two parts. It's almost like a situation where I'm actually controlling that I almost don't weld the back side of this, and I may just and the seam may be left there indefinitely for whatever design purposes here. So it's actually kind of a controlled weld here in the sense that it doesn't want me to kind of destroy the back side of this. That could be why they're controlling this the way that this weld symbol is controlling. So how this looks is let's build those parts. They're a little bit where are they? They're half by 6 mild steel flat. Uh, the last weld was 3/4. Sorry, I never put the parts in. I saw this is my blade. So this is my blade. This is the drawing from 15. You won't know anything, so we have 15. And I never did do a description on that one, right? And so what it was, I think those were I said is it was we were calling it yeah. It was 3/8 by 4 inch flat. Like 3/8 by 4. So I never did like update. Sorry, I'm back on the old assignment, but it's only because I'm gonna make a copy of this part from the old assignment. I'll just show you that like this description in order to populate on my boards should have been filled out as like a 3/8 5 with 3/8 5. Here, I'll still follow. If you put space in here, I don't think it matters as much on the description if it helps. Put the capital here. Uh, this might be following like my in-house stock. supply potentially. Or I could apply a different stuff. Let's see. So 3/8x4 is what we worked with on this assignment for the previous one because we are at 15.3. So 15.2 is what I use this. I'm just going to make a copy of this particular part using this one. I just do a file, save as, I'll just do a copy. And I'll place it in my parts, and it'll be for 15.3. No, I don't want to use this one. I don't want to make it. Then with this assembly as well. Yeah, so still not done with my drawing, but I'm moving on to the next one. So all I wanted to do is be able to open that one I just made a copy of. Apparently it's a size from 15.2, which is I'm going to beg, borrow, and steal it. It's most of the way of what I need. I just need to, it's, let's see what the other side is doing. It's 1/2 inch by 6 massive dot line. It looks like it's 4 inches in this direction and 6 inches in this direction. So I could kind of keep it. It's kind of interesting. I did the other one for the other one that was 3/8 about 4 flat bar. I had my and the 4 inches were quite a bit to each other. It was a different blood temperature. That's fine. I'm just thinking of the do I model the width or the length? But really, I'm going to model this 6 inch. So to me, it's going to be like a 4x6, but modeled the correct way because the flat bar. Well, any way you want to make this 4x6, make sure you make it 4x6. I don't think it's. I think doing that. Let's see. I'm going to edit these sketch them. This is already 4x6. So if I think about that, this is kind of the width. Like when I buy the stock material, this would be the width it comes to. And then I would chop it like, and those stock flat bar lengths come in like some materials like 12-foot length, some of them 20-foot length. And so in order to make something 4x6, you'd be getting this long piece. Yeah, just like a long board, but a long piece of metal and cutting in 4 inches off. And we could go down a deep rabbit hole with the grain structure of the metal and how it matters when you're welding across the weld grain or with the weld grain. Because welding, when it gets, or sorry, metals, when they get forward and extruded, they end up with a grain like wood does in some ways. And when we build things with wood in a grain, the way the grain goes is a huge difference in the integrity of the joint and in the structure design. And the same goes with welding and its metals and their grades and other things. And welding is one that likes to weld across the grade. So for any of those that can get that, that's fine. If you can't understand that, that's fine too. But welding just has a grain, and so it would matter. Like sometimes the things we're doing here and the way that I might have to stop and think, is that the way you would weld it? Because typically on a long piece of flat bar, the grain is down that 20-foot. It's kind of like parallel with that. So this would be a good way to weld that type of metal. If I have a 6 inch width from stock, and I'm chopping it off at 4, and then I'm welding across that grain. Yeah, that would be the correct way to weld something. So you just have to think. Plates are a little bit different, but extruded parts, pipe, a lot of that steel that's shown in those rounds and angle irons and flat irons. And I put up that steel manual yesterday and kind of looked through some of the material types. Yeah, they have a grain to them, a lot of them. Even plates will too, and they'll have and sometimes plates will be under some stress that gets relieved when you put it on a laser cutting table and it gets cut, parts get cut out, and they you see the stress show up as distortion. The forming stress can kind of present itself. Oh my gosh. And in high controlled environments, they make the companies that are cutting plates, parts out of plates, keep the stock numbers on the plates in case there's ever some problem like the Titanic, of what? It's too much lime and some delamination of of the surface. There's metal failure, actually, delamination of the materials. Nothing hitting an iceberg that's going to be walk away anyway. What am I thinking of? This is correct now. 6x4. So I really haven't changed anything. It's just that I'm kind of thinking of it. Yeah, thinking of the material and how it's formed. I'm trying to highlight that to you. The extrusion itself is thicker. It's half-inch thick plate. So if you take like D8s and pop that to half inch. So now that's 6x4 flat. It's a half-inch thick at mild steel, right? Other materials should be generally either just steel or mild steel. Yeah. Okay, so I'm ready to weld this thing together. We'll get into this fast, but I'm pretty thinking about materials. Okay, let's put this into an assembly. Alignment. Place my parts. Of three. Yeah, something. Two of those to make this particular weld. Yeah, this one I think very long too. Sure. Um, so I found in route one, try to pick one and lock down. It is found and rooted. Maybe this is one I can move into it. So ground and root's going to put that in the front view, right? That's okay. We've been spinning it ahead of our. Technically, our weld is going to actually be done this way. Right? We're going to join these two together to like string like this face right to the face. We're going to cut these to a butt joint. We need to keep the top surfaces maybe flush and these end surfaces. And I could have done some plain. I could have done some plain lines there too. So you know me, do one thing one way and next time I'll do it the different. There's my two plates. Of course, on a half-inch thick plate is very thick, and so we would definitely need some weld preparation in this in order to get a really good showing to you, even if we're only trying to preserve one side. So to me, I don't care which side I would actually put this weld prep on it, and you have to flip this over a few more times or which way is up and down anyway. It doesn't really matter. So maybe I'll call this my welded side here. We're gonna do some end. I'm sure we'll end sketches and and put that joint prep in there. So what it's telling me is I'm going to do a 75-degree included angle. That means they're going to shave. Well, it's not a 75 on one on both. That would be 150. So this is actually 75 included. So I just need to know half of 75 is. That's how much I'm going to bevel. 37.5 degrees. 37.5 degree bevel. And I'm only going to weld at 3/8 of an inch deep. So I'm not going to bevel this clear to the edge. So when I go into my parts, do that wet, that maybe weld preparation. Do this weld. I'm just going to do the same thing when I'm drawing on the end of these parts. Even if I just select this surface, I'm going to project geometry of these two. So definitely have their tops there. Again, your bottom here, maybe even the center seam. So just have all this tree. And then what we need to do is we need to bevel from here to here somewhere. So I'm just drawing in somewhere and then a couple of random lines. That would be just kind of constraining them to those lines. I get a little fill on that. Snapping to those lines, that way they are kind of constraining them. And now I'll do that dimensioning. So it's going to be from here to here is 37. And I want it to be the same. You can make it symmetrical, or you could dimension it again. Yeah, there's a symmetry one right here, so if I symmetric. Uh, sketch over to this one. So let's see. And then select the symmetry. Just so you know, there is a command line. Like I don't point to it too much, but every once in a while I will glance down. It locks your command line. It does have like CAD does. Mine's clear over, my command line's clear over here. I probably put these sizes. So there are a few functions to down here on this very lowest, like a status bar here, but it will read out some of the steps if you wonder like what to select first. Just pay attention to that line. That's what I need to do there. Is like, oh, select first, select second, select symmetry line. That's what was telling me down below. So that is the way I got that applied. And then this thing can't go that low. It needs to go up here. And we have a depth associated with that. We are going to take that theoretically forward too, right? Like this needs to be 3/8. That's not constraint this sketching pattern. I must have had to that. It's 75. That's Get this up. I think it is a point. So that's what the joint prep would leave. That would definitely leave some material here that is not being prepped, nor am I probably welding through it. It's actually being stopped here. When the weld gets put in, it will consume some of the bottom of that. And so I'll go ahead and finish that off and screw that. Let's go through. So there's my weld prep. Now I can do my weld. So I'll say weld, it's going to be a groove weld. I think it is. Let's select these four face welds. Edge set one to this. Edge set two or face set, sorry, remove that. And I apply that weld. Aluminum. So I'm just going to change this. I think on my imagery that I have up on Canvas, I might have kept it aluminum. It almost just like shows it better. Otherwise, it just looks like two lines. So I think that's the only reason why I kept it. But technically, I've been switching this to the correct kind of metals. It's all mild steel. I'm going to weld it with mild steel. And say return on this. Yeah, I'll return on that. And then we'll go and add the weld symbol. But yeah, what it's going to be is that it's kind of unrealistic to the welder to think it's a 3/8 depth of weld. Yes, 3/8 weld, but I'm going to allow, I'm going to make sure I have an effective throat of a 1/2 inch. And the reason why that could be controlled that way is I thought of this a bit wrong. But I don't want to burn through, but I don't want to make sure that because somebody's worried about burning through, they don't get good fusion. And so I'm going to require that like 1/2 inch effective throat to be measured. And I'm still going to probably allow them to finish flush, at least flush, if not a little convex here. But in the event that they do finish flush, I'm still going to have to measure this through here and have like a 1/2 inch of left. And so, and then I may be also trying to preserve not burning through the other side. So I don't know, it's just a little complicated here. I think you could also interpret that it is going to be, I am going to consume all this and use my effective throat or my kind of my actual size of my weld to consume it all, and I'm okay with this. And so this could be a weld that's performed that way too, is that I get a 1/2 inch of effective throat out of my weld here, and I do consume that entire parent metal that's touching, and I do end up with a finish on the backside that's here. It's kind of like there wouldn't be a crop there, but it wouldn't be how I'd want it. So, see, I don't know. This one, me as a welder, I need a little explanation. I'm trying to preserve the backside and still keep a 1/2 inch, if I can throw it in my weld, or are we like trying to push all of my potential to dig into that little bit of material that's unbeveled and try to absorb it into my weld. So I could strategically, get my machine and my procedure set to do either way, either preserve the backside, have a little more convex weld, or get a flat finish weld and consume all of the unbeveled material. So this kind of could be interpreted a couple different ways. Okay. Maybe the procedure behind this weld symbol would be required to help me really, what the procedure looks like is more paperwork, and it's just a documented welding procedure. And it's been done by either a welding engineer with it's a CWI or some certified to actually qualify the procedure with the process and this particular joint preparation and matching this weld symbol and figuring out working with a welder. I mean, when a welding engineer or a certified weld inspector is like writing a procedure, they're probably going to have to get a good welder. One of the, I mean, they don't just pull some bum off the street. They bring somebody that's going to know how they want them to do it, and one of the more talented people that come in probably from the organization, the company, or whatever, and help them write this procedure because it's got to be tested, and it usually has to be sent off to qualified testing labs to do some of the tests to qualify the procedure. So it's expensive. So it's like this big to do, and I mean companies are doing it all the time as materials change, or they're going to try to join, they try to join certain materials or certain thicknesses, and we got to You got to qualify the procedure. So it's just a big, it's just like the welding engineers and chief welding inspectors do. And there are a lot of pre-load, I mean, some code books have it's, they just pre-qualified codes, joint design and weld procedures. So there are pre-qualified procedures in some things. And that helps save some money. And you design your work behind pre-qualified joints and procedures, then that can be a pretty cost-saving measure. So some code books have pre-qualified procedures. We try to stay within the bounds of, okay, let's detail this thing. Let's do another thing. 10 foot here. Slow that nice. Slow that nice. And let's put that assembly on there. I may have to save this assembly as well. Might be. Save this. Might be okay. Do that. We'll put it on that drawing. We'll just place this thing. They just end up putting this. The VF in the front view. This is, I'll just do the same thing and we're going to provide assembly for the other stuff. Oh, one thing I will do on the part itself, though, because I know I want to open that part for you. I did open. Did I update the other properties? I know I updated it on the original file. I just not want this file to use now. That's not. So I did update it on the first part. I copied this file. So I need to do like on there and I can remove this. Yeah, six and plus. You'll find spell check doesn't apply. Some stuff. You know, I think weldment is one. I don't know in the picture. You know, this is vector weldment. And in welding, we call things weldments, maybe assemblies. Okay, so back to the drawing here. Let's detail this weld symbol. So it's this thing, I point to it, the arrow side of it. Yes, so we it on the arrow side. And just go ahead and set no preset here. So it's only arrow side welding. And we're not doing a fillet weld here anymore. So I'm definitely doing not just a single bevel, but a double bevel or a V groove. Right there, V groove. I love it. Our included angle was not 40 this time, it's 70. So each one is 37 and a half. And then we have this like actual size weld that needs to be a measure that's a half-inch effective throat and kind of a maybe more theoretical size is 3/8 here. I think that's it, right? It was all we really were adding to this speed fab. Arrow side. Yeah, I think that's pretty well what we're doing. You can add these other dimensions in my thing, in my parts list. All that went good. Yeah, good.